Alright, so this will be a review of 6.2 using the worksheet that you got for practice on Monday, March 4th. And then if you need additional practice, I put up the key for 6.2 worksheet number 3. And then obviously any of your quizzes or any of your homework questions will help review for the quiz on Monday. Again, that's a partnered quiz on Monday, same partners as the one you did right before. Alright, number 1. Here we go. So this one, when I'm looking at it, it looks exactly like a rule. And the rule that I'm thinking of is the derivative of sine inverse of x is equal to 1 over the square root of, 1 over the square root of 1 minus x squared. Therefore, since it looks exactly the same, that must be the rule. And this is sine inverse of x plus c. Alright, number 2. Looks kind of similar. It has the minus, has the x squared, but it doesn't have the 1. So I'm going to first in my mind think, well, what happens if I try to do a u substitution with the whole denominator? And I get this as my derivative. Well, the problem is you don't have this x multiplied by. And because that's missing, it tells you that substitution will not work for this. Therefore, I am going to try and simplify or graph. So those are your 3 methods that you have: simplifying, graphing, or doing a u substitution. So to start off, I'm going to simplify this. So I get that I want that to be a 1. So that's exactly what I'm going to do. I'm going to force it to be a 1 by factoring out the 25. And when I do that, I get 1 minus, and factoring out means dividing by that value, which is how I get a 25 at the denominator of that fraction. And it doesn't look much better, but there's some things we can do. The square root right here of just the 25 is 5, so I'm going to pull that in front of the integral so it doesn't confuse me. I'm going to also rewrite this value as something squared, because that's kind of the frame of the derivative of sine inverse. So the values that I would have to use would be 2/5 x, because 2 squared is 4, 5 squared is the 25 in the denominator, and then the x squared. Now that you see that, you should be able to notice that this inside right here is our u. So that's what I'm going to do. I'm going to use u equal to 2/5 x. I'm actually going to go across to save a little space. Du dx is equal to 2/5, and then I'm going to divide by 2/5, which would actually be the same as multiplying by 5/2, equals dx. And that's what I'm going to use in my next line. I'm going to do my substitution, and I'm going to leave my 1/5 outside. Integral dx is now the same as 5/2 du divided by the square root of 1 minus u squared. Now, if you're a little confused, this 5/2 is just multiplied by du, so I can just multiply that outside instead, since I'm multiplying by that fraction. Integral of du over square root of 1 minus u squared. And then simplify these 5's. I get 1/2 sine inverse of u plus c. Therefore, my final answer would be 1/2 sine inverse of u was originally 2/5 x and then plus c. Number 3. I'm going to actually rewrite this for you so that you can see it a little bit better. I'm going to rewrite this as 1 over x times 1 over ln of x times dx. And I know that the ln of x's derivative is 1 over x, and this is sitting right here multiplied by my u, or multiplied by the dx, and that tells me that I am doing a correct substitution. So I'm going to multiply by x, I'm going to multiply by dx. That's the substitution I'm going to use. Let's come over here. I get 1 over x multiplied by 1 over u times dx, which is x du. This x cancels with this x here, and we end up with the integral of u to the negative 1 times du. Well, u to the negative 1, if you add 1 to the power and try to divide by that power, it doesn't work. That's kind of our hint that it's an ln, if you don't remember that every single time. So it's the ln of u plus c, but then u was originally ln of x. Therefore, there is your answer. Number 4. So I'm going to rewrite this guy also, and you should notice that it's very similar to the problem that we just did a second ago. I'm going to have u be ln of x. I want du dx to be 1 over x, and then multiply by x on this side, multiply by dx on the other side, substitute in. So we get, oopsie, forgot my little symbol. We get that the integral of 1 over x, square root of u times dx, which is x du, x's will cancel, and I get the integral of square root of u du, which is the integral of u to the 1/2 power. So 1/2 power, add 1 to the power, divide by 3/2, which is multiply by 2/3, plus c, so my final answer is 2/3 ln of x to the 3/2 plus c. Number 5. So number 5, if I wanted my u to be 8 plus x squared, I would need a 2x, meaning I need an x to show up right here, but it obviously doesn't because I wrote it in. Therefore, this substitution can't work, so we're going to try to do the 2 other options, graph it or simplify it. I am going to give you the hint that this is really coming from the rule, the derivative of tan inverse of u is equal to 1 over 1 plus u squared du dx. So that's where the rule is coming from. So I'm going to use that by simplifying. So if that 8 was a 1, this would be perfect. So I'm going to factor out an 8, make it a 1. When I factor out, it means I have to divide by the value I was factoring out. Oh, all right. So I'm going to pull my 1/8 out in front of the integral symbol. I'm going to rewrite my x squared over 8 as something squared, and that something would be x over square root of 8. Square root of 8 squared makes 8. Now I can see that that is my u. So I get u is equal to x over square root of 8. I'm going to go across. Du dx is equal to 1 over square root of 8. I'm going to go across and multiply, so square root of 8 times du is equal to dx. We're going to use that in my problem, and I get 1 over 8 integral of dx, which is square root of 8 du, all over 1 plus u squared. Now, this can multiply by 1/8 and give us the root of 8 over 8, and then the rest of it's the rule tangent inverse of u plus c. We're going to rewrite it. Now this simplifies to 1 over square root of 8. How do I know that? Because this is 8 to the 1/2 power divided by 8 to the 1 power. All right, tangent inverse of, remember the u was x over root of 8 and then plus c. So there's my final answer. And no, you don't have to simplify your radicals or your radicals, your rationals. You can leave a square root at the denominator of a fraction. Number 6 looks extremely similar. The denominator was the same, but the difference is there's a multiply by x, which means I can substitute. I'm going to take the whole denominator, and the derivative is 2x. We're going to divide by the 2x equals dx. Therefore, I'm going to do the integral of 5x over u times dx, which is du over 2x. So we know we did it right because our x's will cancel. I'm going to rewrite this as 5/2 integral of u, 1 over u, oopsie, 1 over u du. So this is the same thing as u to the negative 1 power. So that tells me that this is the ln of u plus c. Substitute my u back in, and I get 5/2 ln of 8 plus x squared plus c. So number 7, I added 2 problems, which I didn't feel like were represented well in the review. So number 7 and 8 are my added problems. They review concepts from before. So in this problem, you have 5x squared minus 4x, whole thing squared. So I'm going to have us look at, what if you tried to do a u? And the inside is this. You should realize right away that that will not work because you would have needed 10x minus 4. So, and even if you factored out a 2, you would have still needed 5x minus 2 to show up multiplied by dx, and it does not. Therefore, this is not a u substitution problem, but instead it must be a simplify or graph problem. So I'm going to try simplifying. I am going to distribute. And when I distribute, I get 25x to the fourth minus 40x to the third plus 16x squared dx. Now that I have that, makes the problem a lot easier. 25x to the fifth power divided by 5 minus 40x to the fourth power divided by 4 plus 16x to the third power divided by 3 plus c. Therefore, my final answer, 5x to the fifth minus 10x to the fourth plus 16 thirds x cubed plus c. And then number 8, also a new one. Looks very similar to problems we've done. You've had something like this on almost every single integration quiz. You want to simplify. So the simplifying would be you're going to take every single numerator and divide it by, this is the same thing as x to the 1/2. So I get 4x to the fifth power, oopsie, that's not an x, to the fifth power divided by x to the 1/2 minus 6x squared, x to the 1/2 plus 2x, x to the 1/2 plus x to the negative 1/2 over x to the 1/2 minus 1 over x to the 1/2. Alright, so then I'm going to rewrite this, dx. This would be 10 over 2, so I get 4x to the 9/2 minus 6x to the, this would be 4 over 2, so 3/2, plus 2x to the 1/2, plus x to the, and if I subtract 1/2, you get negative 1 power, and then this one, you just have negative 1/2 power. And then now, finally, now I'm going to take my integral, which means I don't write this symbol anymore. I would add 1 to the power, which is 11/2, divide by that, which is the same as multiply by its reciprocal, minus 6, add 1 to the power, multiply by its reciprocal, plus 2, x, add 1 to the power, 3/2, multiply by the reciprocal, plus, that's add 1, but it won't work, so that's ln, and then minus, add 1 to the 1/2, and then multiply by 2 in front, plus c. Therefore, my final answer for this guy is 8 over 11 x to the 11/2 minus 12 fifths x to the 5/2 plus 4 thirds x to the 3/2 plus ln of absolute value of x minus 2 x to the 1/2 plus c. Alright, last two. Number 9. Again, if you tried to use u is x squared minus 9, you get du dx is equal to 2x, but I don't have x multiplied by dx at all. There is an x in the denominator, but it even has a plus 3, and that did not show up here, and it would not cancel. Therefore, this can't be a substitution problem, so instead, I'm going to try to simplify. You'll notice that my simplifying is my next thing that I do, and we do get this simplifying pretty nicely. My antiderivative, x squared over 2 minus 3x, f of 4 is 4 squared 16, divided by 2 is 8, minus 12 is negative 4, f of negative 2 is 4 over 2 is 2, negative 2 is 6, 8, and therefore negative 4 minus the 8 equals negative 12. But I want to kind of help you understand why that works. So if you understand what the graph of the original function is, alright, so what the function actually looks like, it actually looks almost exactly the same as this here, x minus 3, except for one little thing. And I'm trying to just use the slope. There we go. And then down over. Alright, so it pretty much looks like a line. I mean, it definitely looks more complicated, that x squared minus 9 over x plus 2. Oh, x plus 3, I mean. So that orange line is almost exactly the same as that graph, except for there's actually a hole or a removable discontinuity at x equal to negative 3, which is why you can still take the net signed area from negative 2 to 4. And that net signed area is negative 12. All right. Last one. Number 10. Absolute value. Anytime you see an absolute value in the integral or an absolute value in the derivative, you're probably going to graph it. So, I'm going to graph. So I'm going to say that one more time because you've had one of these on every single test or quiz for integrals. Anytime you have an absolute value, you cannot integrate it. So the best thing to do is attempt to graph it. And if you don't know what the graph looks like, you make a table. And your table should not go by integer values. Why don't you count by something like a half or 0.1? Something where you are looking at the non-integer values so you don't get an incorrect graph. In this case, this is an absolute value graph shifted down to. So I know what the absolute value graph looks like, so I am not going to take my time making a table. We're only going to negative 1, and then we're going to positive 4, so that'd be here. And then I'm going to do a net signed area from here to negative 1. What you should be noticing is the fact that this triangle here and this triangle here actually have the same area. They both have a base of 2 and a height of 2. What that means is these green triangles, they negate each other. The area of this triangle here is 2. The area of this triangle is 2, but the integral with this would be a negative 2, that would be a positive 2, therefore a 0. So I only need to take the net signed area of this shape, and that shape is actually a square plus a triangle, except for it's below the x-axis, so I'll put a negative symbol. In front, the square has an area of 1, the triangle has a base of 1, a height of 1, therefore my area is negative 3/2. There you go. There are all the problems plus 2 extra just to kind of help you. And again, remember, you have plenty of homework and worksheets that you can use to kind of practice for the quiz. Thank you.